Hi students, hope you are doing good, and some of you people had even written the IES exam also, and you people are really preparing well. Now coming for today's session, the today's session is actually simple bolted connections, and it is part 3, because if you take the previous session I teach you about the specifications of different bolted connections as per IES 800 2007, which is based on limit state method, right? Now in this session, in your previous session also we covered few problems, so few more problems were remained. So in this session we are going to complete the problems that are remained in simple bolted connections. Now before I move to this this session, I just want to introduce myself. I am V.Tilak completed my master's degree from University of Sheffield, and I worked as head of the department and also worked as a research engineer or research scientist also. This is briefly my background. In addition to that one, I am also working as a design consultant, independent design consultant too. Had over 12 years of experience. This is my brief introduction. Now if I come to the session today, before I come to the session for today, the number of days that are left are only 34. Hope you are preparing well, and if you have any queries you can post, and you can get your queries get clarified. That is the basic intention behind these sessions. Now in your previous session I just want to jot down what you had seen. In your previous sessions you had seen the specifications of simple bolted connections, specifications of common bolts or black bolts, the specifications you had seen. In addition to this one you had seen, in addition to specifications, guidelines for design of simple bolted connection, design of simple bolted connections you had seen, and few problems, like only 2 problems, of course few problems were done, right, on these simple bolted connections. Now in this session, this is about the previous session, right? Shivam Garg, good evening sir. Good evening Shivam. DIY Prasanna, hello sir. Hello Prasanna, hope you are doing good, both of you are doing good. Yeah. Shivam Garg, sir, I am weak in steel, please help me to get good rank in GATE. Definitely Shivam Garg, of course tomorrow is a session on doubt session. You can ask all your doubts regarding to this steel structures. We are able to clear all your doubts tomorrow, so tomorrow will be a good day for you. Maybe you can ask. Yeah, even yesterday I left many questions in ESC. Okay, it's not at all a problem Shivam Garg, you will see that one. Yeah, yes. Now coming to the first question, of course, as we are our interest is to deal with the problems. I am saying for the first session, first half an hour session, we will work out on limit state method, and after the next half an hour session, next last 15-minute session, we will work out on working stress method, that is for rivets. Okay, Monica, hello sir. Hello Monica. Hafiz Ansari, good evening Hafiz. Mrityunjay Yadav, good evening Mrityunjay. Hope you people are doing good. Yes, right. So let us solve this problem. A single bolted double cover butt joint is used to connect a plate of 16 mm thick with cover plates of 12 mm using M16 bolts of grade 4.6. So you just go through that one. They are expecting here, if you can see, they are expecting the nominal bolt value. So the nominal bolt value, not the design bolt value. I hope you know the difference between nominal strength of the bolt and design strength of the bolt. Here they are expecting you the nominal strength of the bolt, right? And they had given even the bearing factor KB, and they are giving even the shank of the bolts intercept the shear plane. If which shear plane is intercepting which level of bolt, like threads or shank, then it is difficult for you to give a correct answer. So to avoid discrepancy, they will definitely give you even this data also. So for this is if this is the thing. Now if I just want to solve this, a single bolted double cover butt joint. So a single bolted double cover butt joint is used to connect a plate of 16 mm thick. So two 16 mm cover plates are there. These two are getting connected with the help of double cover butt joint. So this is 16 and this is 12 and this is 12. These are cover plates and these are cover plates. Okay, this is cover plate 1 and this is cover plate 2 and its thickness is 12 millimeter if this is the case, right. This is main plate and its thickness are 16 millimeter, and they are getting connected with the help of a single bolted, that means with the help of single line of bolt, that means there is only one bolt line. So in front view you can show in this way, but in the same top view if I want to show, this edge is not visible, right. This edge is also not visible. So let me, right. So this edge is visible, this edge is visible. Now if this is the case, only one bolt line, maybe I don't know the number of bolts in that bolt line, so only one bolt line is here for this joint. So if this is the case, they are expecting, right, they are expecting nominal bolt value. So if you can see the diameter of the bolts or M16 is the diameter of the bolts, directly they are expecting nominal strength of the bolt. So for that one, nominal strength of bolt of diameter M16 bolts. So nominal strength. So without factor of safety you need to do that one. So without factor of safety, in the sense, coming to nominal strength in shear, it has got one equation or one nominal strength, whereas in case of bearing it has got another nominal strength, right. And in this connection, when a load is applied in this way, only these bolts are subjected to bearing and shear. There is no possibility of tension in bolts. So in this one, the nominal bolt strength you need to consider only with respect to bearing mode and shear mode only. No tension mode is required here. So if it is a shear mode, you already know it as you can directly pick as for shear, if I write ultimate strength of the bolt, which is 400 by √3, ultimate strength of the bolt grade is 4.6. So from this one, the ultimate strength of the bolt is 400 megapascal, whereas yield strength of the bolt is 0.6 into 400, which is 240 megapascal. So FUB by √3 into NN into ANB plus NS into ASB. If this is the case, if you see your previous figure, the number of shear planes that are intercepting, for a single bolt, there are two shear planes are here. So out of those two shear planes, I can mention the total number of shear planes are, that is NN plus NS is equal to 2. And one more clue also they had given. The clue is like the shank of the bolt is intercepting the shear plane, and shank of the bolt is intercepting shear plane. So this NS will be there. Shank number of threads intercepting shank will be there. So whereas number of shear planes intercepting threads will be nothing. So this is 0. Shank will be obviously directly 2. So if this is the case in shear, NS is 2. Coming to ASB, pi by 4 into diameter of the bolts. Coming to the diameter of the bolt, if you see, the diameter of the bolt is 16 millimeter is the diameter of the bolt, because M16 is given. So directly you can mention into 16, pi by 4 into 16 square. Like this, if you work out, you can get the nominal strength of the same bolt in shear. So nominal strength out of these two I need to consider is lesser value from your previous from your previous class. Coming to bearing, which is here you can mention ultimate strength of the bolt, just that is required. Ultimate strength of the bolt into 2.5 into D into T into KB. Right, this you had taken. And for nominal strength, there is no factor of safety is required. Abhishek Das, Hello sir, hello. Ultimate strength of the bolt, here it is 400, and D is the diameter of the bolt, which is 16 here. And coming to T, let me say about T. T by definition, if you refer to code of practice, T is the minimum of summation of thickness of the plates which are experiencing bearing stress in same direction. So T is minimum of summation of thickness of all plates, thickness of, I can't say all, thickness of plates, okay, which are experiencing, this is the keyword, which are experiencing bearing stress in same direction, bearing stress in same direction. This is the actual definition for T. So if for that one you need to understand, if a load was applied, if a load was applied, if you take the free body diagram of this bolt here, so how this plate is applying bearing stress on this bolt. So the main plate is applying bearing stress direction in this one, in this direction, and its thickness is around 16, whereas the cover plates are experiencing bearing stress in another direction. So this is how the cover plates are experiencing bearing stress in another direction. So this thickness is 12 and this thickness is also 12, right? So now you tell me, main plates are experiencing bearing stress from right hand side to left hand side, which is 16, whereas cover plates are experiencing bearing stress in another direction. Here you can see, which is I need to mention summation, right? So the plates which are experiencing bearing stress in another direction is 12 plus 12, which is 24. So that means here I just want to mention, here this T is minimum I need to consider, minimum in sense either 16 or 24. Out of these two, which one is minimum I need to consider that, na? So obviously this T value here I need to consider is this 16. And coming to KB stands for bearing factor. If you refer to bearing factor here, which is 0.5, right? So here 0.5. So just that's it. So if you are able to work out these two, the lesser value, that itself is nominal strength. So I just want to mention, they are expected nominal strength. If they expect a design strength, the lesser of this value divided by the factor of safety. The factor of safety when ultimate strength is governing design is 1.25. Shivam Garg says are NS plus NN plus NS, please repeat. Okay, no problem Shivam Garg. If you see NN plus, that is total number of shear planes, whether it is intercepting thread level or whether it is intercepting shank level. Total it is equal to 2. That is what you can observe here, right? So that is what you can observe. So but they are in the condition they are giving, all the shear planes itself are intercepting at the level of shank. No threads are intercepting at the level of threads. So when no shear planes are intercepting at the level of threads, the number of shear planes intercepting the thread levels is 0. So obviously when this is 0, NS value will be definitely equal to 2. So from that one only I can mention, right? Yeah. So this is the way, but you should understand they asked you the nominal strength. If they ask you the design strength, this value divided by factor of safety, which is 1.25, you should consider. And if you expect me to say the answer for shear mode, if it is shear mode na, I can mention it is 92.866 kilonewton. You will get this answer in newtons. But after converting that answer in kilonewton, dividing by 1000, you will get it as 92 for shear mode. Coming for bearing mode, na, I just want to mention which is 128. So out of these two, which one is lesser? The answer is 92.866 is lesser, na? So if I move to the options, 92.866, which is option D is the correct one. That's what I can pick, right? Now coming to the next question, calculate the strength of 20 mm bolt of grade 4.6 for the following case. The main plate to be joined are 12 mm thick with a lap joint. So two main plates are there, one was kept over the other. So in this way, right, and the thickness of this plate is 12 millimeter, right. the strength of diameter of the bolt is M20 is the diameter of the bolt, and you know they had given edge distance, pitch and everything, and for your understanding about NN and NS value, they are mentioning thread is intercepting the shear plane. That is the condition. So if you see, if a bolt was here, how many number of shear planes that you can see here? If I apply a load in this way and in this way, you can observe the number of shear planes here are only one. That means NN plus NS is only one here in our present case. And what they are mentioning, thread is intercepting the shear plane. When threads are intercepting the shear plane, NN will be there. NS is number of threads intercepting the shank level is 0. Only the number of shear planes intercepting threads will only be there. When this is 0, directly NN value is directly 1. So from that one you can write. So here they are expecting the strength of M20 bolt. So they are expecting the design strength. If generally mentioned like strength, you need to work out. So some people has already given Jainamsha is the answer is A. So if you expect me the answer, yes, of course the answer is A directly itself. So if you expect me to solve this, so bolt value they are expecting in shear mode. It is equal to 400 by root 3. This is the permissible stress in shear, divided by factor of safety is 1.25 and multiplied by shear area. And coming to shear area, the shear area is based on the number of shear planes intersecting where the threads are shank, right? So if that is the case, here you had seen only the one shear plane is there. That one shear plane itself is intercepting at the level of threads. In this sense, this is NN is there, and A and B is, if you can see, 78% of cross sectional area of the bolt, which is pi by 4 into diameter of the bolt is 20 square. So whereas if you want to answer for NS value is already 0 now. 0 into any value will also be 0 now. So I don't want to consider that. NS into ASB. So this is the answer for shear mode. Coming to bearing mode, and if you see the connection, only bearing type of stress is possible, and shear mode of failure is possible. No tension failure is possible. So that's the reason why here in this question we are working out the strength of the bolt in shear mode and bearing mode. If tension is also possible on the bolt, then we will work out even the tensile strength or tensile mode strength also. Coming to the bearing strength here, which is ultimate strength of the bolt, which is 400 by factor of safety is 1 point. This is the permissible stress. And coming to 2.5 area, effective area, 2.5 into D into T into KB, right? So the diameter of the bolt, coming to diameter of the bolt 20 millimeter, and here T, what is the thickness of the plates? Minimum thickness of the plate, this is 12 and this is also 12. What is the minimum thickness of the plates which are experiencing bearing stress in same direction? If you take for the top main plate, it is experiencing the bearing stress from left to right, whereas the bottom plate is getting bearing stress or experiencing bearing stress in another direction. This thickness of the plate is 12 millimeter, whereas the next thickness of the plate is also 12 millimeter. So out of 12 millimeter and 12 millimeter, which one is less? So obviously 12 you can consider, na? So here it is 12 is, T is 12 millimeter. And coming to KB, and KB value is not given, but previously in your previous question KB value is given. But to work out KB value here, na, if you see the code of practice of IS 800 2007, it depends on 4 parameters: E by 3D naught, P by 3D naught minus 0.25, ultimate strength of the bolt, ultimate strength of the bolt by ultimate strength of the main member. Ultimate strength of the main member is, if nothing was given, in such case we can take FE410 is granted. So in such case I can mention this is ultimate strength of bolt by ultimate strength of plate. One out of these 4, which one is lesser, na, we can take that as per the code of practice, which is the bearing factor. So coming to bearing factor, the edge distance that was given in our present problem, 33 by 3 into d naught. D naught is the diameter of the hole. Coming to diameter of the hole, diameter of the bolt plus 2 millimeter. If the diameter of the bolt is between 16 millimeter, if the diameter of the bolt is between 16 millimeter to 24, so I can mention here diameter of the hole is 22. D naught is dia of hole, and it is a standard question. Most of the times you can remember directly for 20 mm diameter of the bolts directly in single shear. If it is the case, the bolt value is directly this is the standard one. And coming here, the pitch, if you see the pitch value, the pitch value is 50 is given by 3 into d naught is 22 minus 0.25, and this is 410 by 4. Out of these ones, if you want me to say the answer, this is 0.5 and this value is 0.507. So this value is more than 0.5, which is 0.957. So out of this one, 0.5 you need to consider directly. So if you substitute 0.5, you will get the option. So coming to the first in shear mode, na, it is 45.272 kilonewton, and second one in bearing mode, na, you can directly mention, which is 96. So this is the standard value for M20 bolt in single shear mode. If it is double shear mode, this will not be the standard case. Okay. Now, so if that is the case, you can easily pick the option A is correct one. 45.26. Sir, Shivam Garg, you will get 45 around. Okay. Now, next question. In your previous question, you had seen only one single shear. Now, in this question, you can observe double shear, right? A member of a truss consists of two angles, ISA 100 by 100 by 100, 100 by 100 by 6. So, a member of a truss consists of two angles, okay, which are placed back to back. Okay. So, two members are kept back to back, and here this is one member and this is another member. These two members are connected to a gusset plate. If this is the case, it carries an ultimate load of 200 kilonewton. Of course, the PU is given, is connected to a gusset plate of thickness. The gusset plate thickness is 8 millimeter is the gusset plate thickness. This gusset plate is actually used for connection, right, to connect between two plates. Is placed in between two connected legs. Determine the number of M16 bolts. The number of bolts is design load, which is P by the bolt value, and the bolts that they are expecting you to work out is for bolt value is for M16, but here they are expecting the number of bolts. So load itself is the ultimate load, which is 200 kilonewton. Just you need to work out the bolt value. And coming to bolt value, here you need to work out bolt value, but you can't take directly the bolt value in your previous case, because generally if you see, this is here M16 bolts. So for M16 bolts, I need to work out the bolt value. And before that one, I just want to mention here, there are if I keep a bolt here, okay, or if this is the gusset plate, okay, and here the bolts are in this way. The number of shear planes, here it is 1 and here it is 1, and they are saying here threads are intercepting the shear plane. So two shear planes are there. The total number of shear planes, NN plus NS, is 2 per each bolt, of course. And if this is the case, they are mentioning the threads are intercepting the shear plane. When threads are intercepting the shear plane, NN will be there. The number of shear planes intercepting shank will be 0. When this is 0, obviously that NN value itself will become 2, right? So if this is the case, if this is the case, they are expecting the bolt value. Yes, you can easily work out bolt value in shear, which is 400 by root 3 into 1.25 into NN. NN is 2. Number of shear planes intercepting at the level of threads is 2 into 0.78 into pi by 4 into diameter square. Diameter is 16 na? 16 is the diameter of the bolt, so 16 square. This is in shear, and next one is in bearing, which is 400 by 1.25 2.5 into D. D is 16. And coming to T, you should be able to work out T properly. That is, if this is the case, you can see, if I apply a load here in this way, the main plates will experience bearing stress in one direction, whereas this gusset plate will experience bearing stress in another direction. So coming to main plate thickness, here this is 6 and this is 6, and whereas the gusset plate thickness is 8. So the aggregate thickness of main plates are 12, whereas the thickness of gusset plate is 8 out of 8 and 6. So T here I need to consider as either 8 or 6 plus 6, whichever is less. So in that case I need to consider this 8 millimeter. Na? So here 8 I need to consider. So 2.5 D into T into KB. I need to work out KB. KB is the bearing factor. Bearing factor you can easily work out from edge distance and pitch distance. Edge distance is 30 millimeter and pitch distance is 40. Edge distance is E by 3 into diameter of the bolt is diameter, not of the diameter of the bolt, diameter of the hole. Diameter of the hole is 18. Diameter of the bolt is 16. So pitch is 40 by 3 into 18 minus 0.25. And next one is 400 by 410. This 410 is the ultimate strength of the main members. Okay, so and here it is 1. If this is the case, out of these 1, the lesser value is 0.49 will be the lesser KB value, lesser of this. So out of this I can consider 0.49 will be the answer. So just keep 0.49 as substitution. So if I want to mention the answer, this value in shear mode is 50.176, whereas for 50.716 is for bearing mode. Sorry, this is for bearing mode 50.176 kilonewton, whereas in shear mode it is 90.544. But the question is not about the bolt value. So bolt value is lesser of these two, na? So in such case directly you can pick 50.176 is the bolt value. But the question is 176 kilonewton. You need to mention even the units also. But you will get the answer in terms of newtons. Okay. So now if that is the case, just say 50 point something, 50.176. So kilonewton. So in that case 200 by 50.176. So you require some 3.9 something. So you can't keep three bolts and 90% of bolt. So you require 4 bolts definitely. So 4 bolts is the answer. Coming to 4 bolts, I can mention is option B is the number of bolts is 4. They are not expecting the bolt value. They are expecting the number of bolts. Okay. So next one, here also they are expecting to calculate the number of bolts, 2 plates. But then why I had considered this problem also, but there is a difference in between thickness of the plates. So in which Sir Nagasri Sai, Sir weld is enough. Sir Nagasri Sai, tomorrow we will discuss, the next sessions we will discuss about the weld. Okay, don't worry about the weld. So it is very simple topic and we are going to cover also. So in the doubt session, if you had any doubt about this weld topic, you can ask Nagasri. Okay. Now they are expecting the number of bolts only, and if I want to say 2 plates 10 millimeter, this is first one is 18 millimeter, first one is 18 millimeter, second one is 10 millimeter. So 18 and 10, these are two are connected by a butt connection. Butt in the sense two main plates should be kept side by side. Okay, so when two plates are kept side by side, na, this is how I can keep the cover plates. But you can see there is a gap between this cover plate and this main plate, na. So to avoid to keep this bolting here, na, we generally keep some packing plates. So let me go for packing plate with another color. Maybe this is the packing plate. Okay, so if I apply in this way, these are the bolts here and these are the bolts, and they are expecting what is the number of bolts in this type of question, because in this type of question the strength of the bolt should be reduced because of packing plate thickness. One thing I just want to mention that. Okay, and coming to here, the shear planes. Coming to shear planes here, one shear plane is here, another shear plane is here for this side, but whereas for this side one shear plane is here, okay, and another shear plane is here, another shear plane is here. So there are three shear planes here in this case, but there are only two shear planes here in this case. So but we always, while we are working out the number of bolts, our assumption is in such a case that we always underestimate the things, then only the number of bolts can be increased and it can resist the applied load. So in such case, here the number of shear planes we will consider as 2 only, and coming to Nn plus Ns is 2 here, right. And what the thing they are getting is threads are intercepting the shear planes. When threads are intercepting the shear planes, Nn will be there, and shank level, the shear planes that are intercepting the shank will be 0. So this will be definitely 2. And moreover, the thickness of packing plate, if you see, na, the thickness of this packing plate, this is 18 minus 10, it is 8 millimeter is the thickness of packing plate. When the thickness of packing plate is more than 6 millimeter, in such case reduction in shear strength is a mandatory as advocated or supported by IS 800/2007 as per limit state method, because uneven distribution of shearing stresses will be there. Moreover, I just want to mention this packing plate is a flexible plate. This is a flexible plate. That means if it is a flexible plate, na, it won't apply any sort of bearing on the bolt. So when it is a flexible plate, that flexible plate will not apply bearing. So don't apply bearing pressure on, don't apply bearing on bolts. So that also you should please take care. And yes, let me consider, if this is the case, let me work out the number of bolts of M20. So N is equal to the applied load here, calculate the number of M20 bolts required to transmit a factor load of 240 kilonewtons. That is, factor load itself is they had given. If they had given service load, I need to multiply that by load factor also. So load factor for dead load and live load as per IS 800 or any Indian standard code is 1.5, but it is for earthquake load or for another wind loads it will be 1.2. So that depends also. And Nagasri Sai, sir, Nagasri Sai, prying force may be developed, na? Yes, Nagasri Sai, for flexibility of connection, here that connection we are assuming the packing plate will not apply, will not take care of any load. Because of that assumption, na, we do not consider the prying force here, dear Nagasri Sai. It is not required because we are not designing that. We consider as if in the design itself, its packing plate is just like a covering plate here. It just like a medium that is to be filled. It will not resist any sort of load. Okay. Yes, N is equal to this P by coming to bolt value. So coming to bolt value, so in shear it is different. Coming to shear, if that is the shear case, na, you can write 400 by root 3 into 1 by 1.25 into Nn. Coming to Nn is 2 here. So 2 into 0.78 into pi by 4 into diameter of the bolt. Coming to diameter of the bolt, I think they had given for M20 bolts here. Yes, for M20 bolts, so pi by 4 into 20 square. And of course plus ns into ASB will be there, and ns is number of shear planes intercepting shank is given as 0. And this is for coming to bearing. Coming to bearing, we can mention 400 of course divided by 1.25 is the permissible 1.25 is the factor of safety into the effective area which is resisting the bearing, which is 2.5 into diameter of the bolt into thickness of the plates, aggregate thickness of the plates which are experiencing bearing stress in one direction, minimum thickness of the plates which are experiencing bearing stress in one direction. So T into KB, which is bearing factor. So coming to this diameter now, here it is 20, and coming to T. So coming to T, if you see, this should be underestimated, and here if you can see, if you see this one, generally if you take, this is how the bearing stress is developed on this side. This is the thickness of cover plates are how much? Thickness of cover plates are 8 millimeter. So this is 8 millimeter and this is 8 millimeter. But for this left hand side joint, but if you take the right hand side joint, na, here because this is a flexible element, it won't apply any sort of bearing pressure on this bolt, na. So in that case you can see this is how the bearing this is how you can see when this load is applied in this way. You can only see this is how the bearing stress is applied on this bolt, and this is how the bearing stress is applied on this bolt. But if you see over this packing plate is not applying any sort of bearing pressure. So I need to consider, to underestimate the bearing strength, if I consider the left hand side, it will overestimate if the thickness of the plates which are experiencing bearing stress in one direction is increased if I take the left hand side. So our assumption in the design philosophy is if there are two such practices are there, always our intention is to underestimate the things. In such case, if this is 8 and this is also 8, so cover plates aggregate thickness is 16 and main plate aggregate thickness is only 10. So out of 8 plus 8 millimeter, or next one is main plate thickness, main plates are experiencing bearing stress from left hand side to right hand side, which is 10 millimeter. So out of these two, the least should be considered. So which is 16 millimeter is one, or 10 millimeter, the least one only I need to consider. But if you take the right hand side, you are overestimating. So I am considering here the answer as 10 millimeter. So this is the reason why I picked this problem. And coming to T, it is 10 millimeter, and KB as usually you need to work out. And coming to KB, edge distance, I think KB factor is directly given as 0.5. So directly it is okay. But one more thing you need to consider, this bolt value is multiplied by reduction factor due to packing plates, which is nothing but beta pkg. This beta pkg as per IS 800 2007, if you refer that, in such case if you refer that, it is 1 minus 0.0125 into thickness of packing plate. This should be considered when the thickness of the packing plate is more than 6 millimeter. If it is less than 6 millimeter, the distribution of shear stresses is okay. The more variation of shearing stresses will not be there in distribution. So thickness of packing plate here I can mention as, which is 8 millimeter. So if I work out beta pkg in this particular thing, of course some value will be there. Coming to this value multiplied by this shear value. So in total shear, final bolt value for shear mode, this beta pkg multiplied by shear. If this is 81.489 kilonewton, whereas this bearing mode, in this bearing mode, the bearing actual bearing value multiplied by beta pkg. If you work out that, this is 80 kilonewton. So out of 80 kilonewton and 81, the least value only I need to consider. I need to finalize it as the final bolt value. So the final bolt value I am finalizing it as 80 kilonewton. So here you keep just as 80 kilonewton. So the number of bolts that are required in the connection is 3 bolts. So generally, when compared to your previous problem, you may make a mistake without considering this. This is one possibility of making a mistake if I don't deal the problem, and another possibility of making mistake is this. Sorry, let me show with another color. This T value you may make a mistake, and the number of shear planes you may make a mistake here. These are the 3 chances where you can make. Shivam Garg, sir, I got 3.33 bolts. Just check, Shivam. So 0. Yes, beta pkg you will get. Yes, of course, you will get in this way only. You will get for this top one, na, it is 81.489. For the bottom one, it is 80. Check. In this one only you had made a mistake. I had already done. Sir, where is reduction factor? Reduction factor I already multiplied. Here 1 minus 0.0125, that value multiplied by this. I am saying beta pk should be multiplied by this shear value or bearing value, and that beta value is after multiplying that one only I will get the final bolt value. Okay, right. So you can see it here, Shivam, here this is reduction factor, right? So 3 is the answer. So directly you can pick, na. So this is why I picked the problem, because you may end up with wrong answer if I just tackle one problem, right? Yes. Now coming to the next one. Till now we had tackled only in terms of bearing and shear mode. Now some people will come and ask us, sir, why don't you do any problem on some tensile strength of the bolt? Yes, this is the case. They are expecting the design tensile capacity of the bolts. Previously I didn't consider the tension mode because it is a simple connection over which all the bolts, all the black bolts are experiencing either bearing mode or shear mode, but no tension force is coming on the bolt. Now if they are expecting tension, if they are expecting tensile strength of the bolt, how to work out this? Okay, Nagasri Sai, sir, most probably shear is bolt. Yes, of course, Nagasri Sai mostly, but you can't say always. There are certain cases, of course, generally you can consider, but most probably dominating factor is the shear one. Next, coming to design tensile capacity. So coming to design tensile capacity, design tension capacity. Tension failure can happen in bolts because of 2 ways: by gross yielding, by rupture. Gross yielding in sense the failure stress is yield stress. When failure stress is yield stress is the failure stress. By factor of safety, when yield stress is governing the design, is 1.1. So this Fi by 1.1 is the permissible stress. Okay, and Fi by 1.1, this gross yielding will happen in gross cross sectional area of the bolt. So what is gross cross sectional area of bolt? You can mention easily as pi by 4 into diameter of the bolt square. What is diameter of the bolt? It is 20 square. Fi for this bolts of grade 4.6, this Fi for bolts you already know, 0.6 times of 400, which is 240 megapascal. This is the answer in gross yielding mode. But out of these 2 modes, which one is lesser, we need to consider that. And in rupture mode, that means the bolt will get fractured. In tension mode, rupture will generally happen where the cross sectional area is less, that is at the level of threads. When it is at the level of threads, the actual failure stress is ultimate stress, right? Ultimate stress is the actual failure stress here in rupture. Divided by factor of safety is 1.25. But whenever some rupture due to tension is there, I need to reduce the permissible stress as per code by 10%. When I reduce the permissible stress as per code by 10%, then the remaining stress is 90% of this. So in such case, I need to mention which is 0.9 times of Fu by 1.25. This will be the permissible stress, final permissible stress, multiplied by, I need to consider the area which resists the tension action, which is at the level of threads, cross sectional area at the level of threads, or net cross sectional area of the bolt, which is net cross sectional area of the bolts is 78% of gross cross-sectional area, pi by 4 into d square. D square is 20 square. So out of these two, ultimate strength of bolt I need to consider. So coming to ultimate strength of bolt here, this is 400, right? So out of these two, which one is lesser, we will consider that. Now people will also ask me, so if this is the two things, which one we need to consider? We need to consider only the lesser one is taken as the design one. Let us suppose in the same question, if they expect you nominal tension capacity of bolt, then in such case avoid this factor of safeties and mention the answer. Only consider the numerator, denominator the factor of safety avoid and you mention the answer, right? Nagasri Sai, B minus N into D into T, that is for effective area of the plate which resists the tension action. I am talking about the design tensile capacity of bolt, not about the plate. Hope you can understand. I am expecting the design capacity of bolt, man, not the plate. There is a lot of difference between bolt and plate, dear Nagasri Sai. Okay? Oh, sorry. Now, if this is the case, if you people ask me the answer, this answer is 68.543 kilonewton, whereas this answer is 70.572 kilonewton. Nowadays, most of the guys we are using in practice only the bolts, whereas rivets are not in practice, but still there are some questions can be asked even from rivets also. So that's the reason why. So out of these two, before going to these two answers, the answer that I can confirm is 68 point this much only I can confirm, because the lesser I need to consider. So option is C, you can pick. Okay. So and this problem, a plate of 40 millimeter thick are to be joined. 40 millimeter plate is there. This is to be joined with the help of a lap connection. Lap connection means one plate should be kept over the other. Okay. With 30 mm thick plate. So this is 40 mm and another one is 30 mm. So these are two are connected with the help of a bolt. If this is the case and they are applying some load in this way, this is the case, the design shear strength of the bolt should be reduced. When the reduction in shear strength of bolt exists, whenever packing place exists, whenever something like whenever long joint is possible, whenever long grip is possible, there is no long joint, no packing plate, only maybe possibility is only with respect to long grip. So coming to long grip, what is grip length here? This is the grip length. So grip length here in our problem is 40 millimeter plus 30 millimeter, which is 70 millimeter. And coming to diameter of the bolt, nominal diameter of the bolt is 12 millimeter. And coming to grip length by diameter of the bolt, which is 70 by 12, this is more than this will be more than 5, which is 5.833, which is greater than 5. But whenever you see the grip length by diameter of the bolt is more than 5 and less than 8, less than or equal to 8, in such case I need to reduce the shear strength of the bolt. When this value of grip length by diameter of the bolt is more than 8, in such case I should not use such type of connections in design. So you need to redesign such things, right? So Nagasri Sai, in bolted connection, like packing plate, long plate, yes, of course, long plate is different. This is long grip, dear Nagasri Sai. Because of higher grip length, when the grip length is high, because of such action of P and P, there is a chance like this bolt can bend. This bolt can bend and fail prior to reaching its yield stress or prior to reaching its permissible stress. In such case, I need to reduce the shear strength of the bolt. Permissible strength of the bolt in shear mode should be reduced. That is advocated or supported by AS code, because it is failing prior to reaching its actual strength in bending mode, right? So which is not at all good. So that's the reason why I should apply some reduction factor. What is the reduction factor that I can use here? Reduction factor which is beta due to long grip. Beta reduction factor due to long grip. L stands for long, G stands for grip. Beta LJ stands for long joint. There is no long joint here. The long joint can be there if I know the total detailed connection. There is no such thing, and there is no packing plate also. So beta PKG is also not possible, this is also not possible. Coming to beta LG, so reduction factor due to long grip, which is 8D by 3D plus length of the grip. Coming to D, D stands for the diameter of the bolt here. Coming to diameter of the bolt, which is 12 millimeter, this is also 12 millimeter, and length of grip, LG stands for length of grip, or grip length also people use call. Grip length. Grip length can be defined from the overall the total aggregate thickness of all the plates, including I can mention cover plates also. So grip length is 70 millimeter. So if you work out beta LG, you will get the answer as 0.905. If the reduction factor itself is 0.905, what that means? If the bolt value is 100, I need to consider only 90.5% of that bolt value. So what is the reduction in strength? So from 100 percentage, the value has came down to 90.5%. So reduction is 100 minus 90.5. So in other words, it is 100 minus 90.5, which is 9.5%, which is almost 9.44. In such a way you can mention. So you can pick directly this. If you are expecting me, if beta LG is 9.905 directly, if you are expecting me percentage reduction as a percentage reduction in shear strength as a formula, which is equal to 1 minus beta, of course, into 1 minus reduction factor into 100. This is the way generally I can give answer as a formula if you are expecting a formula, but it is from common sense we can easily make that answer. But you should not make Shivam Gar, don't keep the answer as 90.5. That for your trap they had even given here 90.5 also. But if you choose this answer, you are a gone case, because they are expecting the reduced by how much percentage the shear strength has got dropped. That is indirectly the question. So what is the percentage that was remained? It is not the question. How much is the percentage of shear strength that has got dropped? That is the question. So in such case, remained is 90.5%. So last shear strength is roughly around 9.5%, which we can indirectly we can write as 9.44. If you expect as a formula, this is the thing that you can practice. Now, right. So for today the session is time is over now. So I just want to mention there are in this remaining two problems or one problems we will deal in next doubt session. I just want to mention, it doesn't mean like we are not interested because of the time content that was given to me in the studio. It was at max it was booked only for 1 hour, right? So we will deal the remaining questions. We will deal the remaining questions in next class, or I mean doubt session. Shivam Gar says, sir, if he says reduce to, if he says reduce to in sense, then in such case Shivam Gar, your answer is correct, 90.56. It's all depends on the wording how he has given. Shirisha Nambi, sir, when you will start for 2021 gate? That was already there. We already started. That the free trial session is there, and they will give you. We are about to start from 20 of Jan. We are starting sessions for you, and preview period is also there, and of course you are coming for every day the sessions. You can start the classes. It's a paid course for 2021 gate, and we started for ESC and gate together, and of course in addition to that one, some free courses will also go in addition to that one throughout the year. This is the answer for Sirisha Nambi. Okay, yes. So you can have the access for these yearly cards and monthly cards. If you want to crack any examination, should have some good practice. After any teacher will teach you, his contribution may be 60%. Remaining contribution you should develop on your own by practicing more number of problems. So I can suggest you, so go through these problems by using these yearly cards and monthly cards, and you will have access to so many varieties of problems. And yes, prepare smart, score better. Go Gradeup. So if you have any problem, of course the time is very less for 2020 guys, or anybody. If you want to have any discussion, you can come down to our platform of Gradeup, follow me through Gradeup app just by typing V.Tilak. Okay, just you type in Gradeup app, install your Gradeup app and register for GATE Civil Engineering, and if you type V.Tilak, follow me and you can post your queries. Either me or the other mentors who are ready by that time will help you to solve your queries. Thank you very much and don't miss our sessions. Shubham Kumar, sir, please add civil engineering test in green card. Yes, of course, we already added a civil engineering test. It was there in the dial-up box. In the dial-up box, just you got now, Shubham Kumar. You can press over that. Okay. And don't miss my videos. Please press the bell icon so that all the videos that are coming in future will be notified to you. Tomorrow is also my session is there, which is doubt session. So whatever your doubts in the entire steel structures, okay, you can ask me because the time is less now. I am ready to solve all your doubts. Maybe I may not solve all the but I will definitely give the reason and I will definitely give the way how you can solve and the reason behind that. And thank you very much.